Okay, thank you. I want to start just to mention that this is a collaboration happening with research, that is the research lab I'm from, that it's on legibility research and typography, and the Data Science Institute, where Christopher, that is a PhD student there with and the supervisor, Dirk Falkenberg, while I'm supervised by Anne Besmans. That works into that works into data science and help with the data analysis and the statistical methods that we have used then to develop this research. So first of all, the research is framed into the Latin script, and it is about all the Latin script languages that are all around the world and all different. We are familiar with this way of clustering languages based on linguistic families. However, this research wants to focus into the visual diversity of languages. So that is usually a bit overlooked, as we can see when we open, for example, any layout program or software like Microsoft Word. We put any kind of language there, and the standard default is the same for all these languages. Anyway, when we have this same typesetting, same layout, same typeface for all these languages, we are still able to see this visual diversity because of the different text colors that comes out from the text. And these are generated by specific design features that are coming out from those languages. That is to say, the accents or the or the different word lengths that languages can use. And those features shapes the black and white of the text. Black and white is then connected to legibility research and in particular rhythm. And rhythm is this alternation of black and white strokes as in regards to the typeface design, as also was designed by Anne Besmans and furtherly with Professor Anne Doms, that is also co-supervising this PhD research. Based on neural networks and algorithms, so to create it automatically. And the other way of looking at understanding rhythm is in relation to the text lines. So it's an horizontal rhythm. The rhythm is important because these stripe patterns, if looked for long times, can cause visual stress, migraine, and general discomforts. And there is a specific ratio between the black and the whites that generate this discomfort. And language seems to have an impact in the rhythm, and at the moment is not considered in the construction of the rhythm, either horizontally. We are ignoring the presence of diacritics and of ascenders and descenders. As well, the word length can also have an impact into the blackness of the text line. And also for the vertical rhythm, there is a linguistic language visual diversity that is not considered in relation to the ascenders and the diacritics. So language, in brief, is shaping the black and the white of the rhythm, creating different shades in the horizontal and the vertical stripe pattern of the text. But on the other way around, designers and we as users of software and design and layout, there are other parameters that are related to typesetting, that is letter spacing, word spacing, line spacing, that can be used to change the black and white of the text, in particular the white of text. And designers have always looked for this balanced text color of the text and to look for and to seek comfortable reading without having a framework, a base and a foundation into legibility research and scientific research. So what this research wants to do is to connect the language design features, so the different way languages shapes the text, to typesetting, so to the spacing features that typography and typographers are used to reach visual comfort. So the question is how language diversity is having an impact into this, into typesetting and legibility. To do that, we focus, and this presentation will mainly focus on language. To do that, we needed first to design a system that enables to categorize and classify the language rhythm. In that way, we designed this deconstruction system that deconstruct letters into top and bottom parts based on the text line and on type design practice. And also vertically, the letters are understood as shaping how the stroke of the letter is shaping the space on the right and on the left side of the letter itself. This is the system that has been used then to identify these 33 design features. So that I will I will show you a bit faster because I want to arrive to the work that we did with the Data Science Institute. And the features are basically the concept of the how language is shaping black and white in the text. And we can see examples of the feature and then examples of languages that are using in an extreme way the feature that is shown, and a language that is not using that. These are how we are categorizing all the letters, and how languages are different because of those features that usually are to be understood in combinations. So we have features referred to the shape of the letter, to the stroke, and to the position. Based on these 33 features, we have an understanding of how language and a mapping of how language is shaping the rhythm of the text, either horizontally and vertically. And then based on this, we arrived to define language clusters, meaning those groups of languages that are using in a similar way all these design features. And this will enable us to advance also legibility research across different languages. And here comes the statistical methodology that in which Christopher and Dirk assisted us. So based on these 33 features, with statistical methods, we got this hierarchical clustering. So this graph that we can see the languages on the bottom. So this method placed the languages near when they are similar in the use of those features, and far away when they are not similar in the use. So we can visualize what are the languages inside the clusters that have this similar use of the typographic features, but we don't know why those languages are inside those clusters. So which are the design features that are actually defining the clusters and the languages? To do that, we applied another method that is this PLSDA. Basically, starting from the complete framework of these 33 features, it was impossible to visualize a 33-dimensional space of features. So those were divided into two components that then define a two-dimensional space. This means that we have a first set of features that push languages even rightwards or towards the left. The languages that are highly in use of those, for example, one stroke, open, top composed. So those languages that have these features that are highly in use because it's all about the frequency are pushed towards the right, not the left. And then on the way around, they are pushed towards the yeah, you see it's left. Okay. And and here we can start to see how languages are derived and located into this two-dimensional space in attention that is defined by all these features working together. So any of these features is definitive into locating a language in the space, but they are all working together. And the same way we have with the Y axis. So languages that are features that are pushing upwards or downwards the languages, and here is the outcome, and then in the total vision of this feature space is that one. And to give you an example and understanding of what we are actually looking, but basically this system is not predicting the clusters, but is validating what the hierarchical cluster was already showing. So the languages that are near are a cluster, the ones that are far away are another one. To give you an example, the languages that are using a lot of diacritics are pushed more towards the right of the graph. So we can see, for example, Czech that is a higher user of the diacritics, and another language that is on the other side that is lower in that use. And this is also happening within the same cluster. So this explains you better that there are also other features that are coming into play into this space. So we can see that English is more towards the left because of the lower use or the no use of diacritics, while French, that is in the same cluster, but is a bit moving towards the right. I'm sorry, with left and right, I think I'm making mistake, but I'm thinking. And another example, it was with long words. I will just show you. So languages that are using long words are down here, and those that are not using, it's up there. And again, like we see with English and German, that we know German has a lot of long words, but it's a bit slightly going down rather than English. What is happening and that we still have to explore is the diversity that is also inside the clusters, because as you see all the gradient of the languages, so the ones that are darker are more representative of the feature space of that cluster, while the other ones are still inside the cluster, but more in the borders. So we still have to explore which is the behavior of those languages. So like if the visual behavior of those that are in extreme positions is the same of those that are more central or extremely on top of the representation of the feature space. As well, the 4 clusters that we have identified, we have to still explore the relation and the distance that is happening between the clusters. So it's not just the space of the languages inside the cluster, but also the general space of what is happening between them. Another way that we can have to understand the cluster inside this bigger framework that we are working in is the relation that the visual cluster system that we are presenting has with, for example, linguistic families. So here is an example that we can see that the method that we have used is based on the visual features. So Romanian, that is a language that is usually clustered with Romance languages because of the use of accents that make that more near to Slavic languages, for example, is going in another cluster that is the green one. So that reveals what we have used as a criteria to make the clusters. Then the other ones are almost all matching. As we can see, the match with geographical clusterization of the languages, sort of correspondence that we can see there. And another way to explore and understand how this visual approach to language can be framed into a wider context is connected to the writing roots of languages, as not all the languages before using the Latin script were using another script. So how this then connects to the original script and to the way that we are actually seeing the languages. So for example, the runes that connects to Germanic, then connects to this group of languages. So to go to an end, the next step is to understand how these design features that allow us to approach languages in groups and not in their singularity can help us to drive more cross-linguistic research into legibility and to connect then, the idea is to connect typesetting, so word spacing, letter spacing, line spacing, to reading comfort. That means this experiment that actually we did, we are still analyzing with the Data Science Institute, and with how readers perceive reading comfort across different languages. So this is some bibliography that maybe you don't read, but, and thank you. Oops.
Are you happy to field your own questions?
Huh? Yeah.
Okay.
What you asked?
Oh, so just pick whoever you want to.
Yeah. Okay. I will go on in this way.
Okay, can I begin?
Yes. Just pick.
Okay, so if I understood the process, I wonder how you selected the font to measure things. Because you know that if you use an old style, you will have a much more difference between the straights and the rounds. And you have more narrowness in certain letters. And that can, let's say, the high repetition rate of those narrow letters can alter the way that you measure. So what was the process for that?
Okay, so first, the idea is to try to abstract from the typeface.
From the typography altogether.
Yeah, from the typeface in particular, because it's right, there are differences in rhythms because of the different typeface. The typeface I'm using is the Bookerly typeface, because the context of reading of this research is continuous reading and digital reading.
On screen.
On screen.
Sure. And that was my second.
Yes. Yeah, and so yes.
It's fascinating work.
Thank you. Yeah.
So I have one question and one shameless plug that they are related, so that's an excuse for me. The question is, what kind of tooling, what kind of tool stack do you use for your work? And the shameless plug is, if you want to play interactively and in real time with letter spacing, word spacing, and everything to try to figure out what's best in terms of readability. For instance, this is spot on something that I'm working on right now, and I might have a tool that you would like to try. So we need to talk.
Okay.
But then the question was,
yes,
the question before, it was what kind of tool do you need?
So tools for doing what?
For statistical experimentation, how do you gather statistical data?
Okay, I think this question is for Christopher, that I think is also online. No, but yes, actually, I don't know what tool he used. I think it was programming, maybe.
But are you referring to how we did the clustering, or how we did the methodology
How do you measure the different typographic parameters?
No, this was done like in this way, like I've defined all the features, and then we started by using the letter meter that was developed at the by, I think, Peter Bilak at the KBK. That was originally used for that it didn't have these features inside, it had other ones. So basically it's measuring letter frequency. So based on letter frequency, we got data into coming from a text corpora that was the Bible in all the languages. So the full text, because it's a lot of text and it's diverse. And then from there we obtain the data that then Christopher had to process processed, I think, with Python or some stuff like that. And yeah, that's the thing. Yes.
I have two methodological objections. The first is that you make the implicit assumption that all of these languages can be typeset with the same font, which is not true. I mean, commercially, you can do it, but it's a compromise, a simplification. In German, the dots are lower because the umlaut is a phonemic function, while in French, the dots are higher because the tréma is a segmental property. So when typesetting German, your dots are lower. When typesetting French, you also have to align the dots with the accents, so they are higher. But you're using exactly the same font for all languages.
Yes, but I trust that the designer of the typeface has taken into account this.
Ignore the differences between two languages. Okay. And my second objection is on the typographic specificities of each language. The example you gave of French, you have all double punctuation without spacing. That's not French. In French, there is spacing. And since you are measuring visual parameters, I think that punctuation is important.
You did not take into account.
No, I didn't took into account punctuation because all the concept is not just language diversity, but is the rhythm of the language. So the
Punctuation is very important.
no, the reason why I didn't took it into account is just because rhythm is defined by something that is extremely repeated. So in this case, we were not like I didn't took into consideration punctuation because like it was something that at the beginning was thought to be considered. There's also phonemes and more stuff that is related to language diversity. But then in the creation of the overall texture, by also looking at the different text that languages are creating, that I don't know, but is just like this this slide. Where is it? Too much. So here we can see like there are interruptions that can be made by the punctuation, but the thing that is making the rhythm are, as was designed here, are the strokes of the letter and the text lines. Maybe further research can be also about implementing punctuation, as here were ignored the ascenders, descenders, and were ignored the diacritics, but diacritics and like these like diacritics are more prominent into the design of a text because are more used and more frequent than can be punctuation. So this is the reason why it's not considered. Then I agree it's something that is making the diversity. Yes. There is the expert. Okay, so rhythm actually is a research line of the research that was started with the PhD of Anne. Where actually she constructed this, she found out this visualization of, maybe it's not this one, but so this stroke alternation that is vertical, and in the Latin script, the predominant rhythm is the vertical rhythm. Then the concept of black and white, so repeated line is also into the horizontal rhythm, and because rhythm has been also not related to ascenders or to diacritics, in this PhD there is also this extended version of the rhythm theory, but that actually has been studied and proved to have also connection with spatial frequencies. So these different ratios of black and white. So if the thickness of the white and of the black of the stroke is the same, it can cause more this pattern glare and discomforts. And
It's a platform that, like, as the slide is now showing a very homogeneous pattern, but how I started this research line is that it seems that there are legibility differences when it comes to decoding for specific groups, where it becomes more heterogeneous. And that has always been like not studied. So in that sense, it has become an important research line on which also Marta is investing a lot on. But yeah, as the more homogeneous for some audiences, the more discomfort it causes. And that's why there's this analyzation and trying to see which glyphs and which part of that glyph adds to this proportion, and can not only give us clues into how to study legibility, but also give clues to designers, how they want to design valuable forms of the DNA. Really interesting.
yes,
I was gonna say that which language is the simplest with the Latin alphabet, it might not be English. So
Or in Latin,
No, I think it
probably
was,
Latin.
wasn't it Basque?
Probably
It was
it's
the
Basque.
origin.
that correct, or
I haven't.
Which language is the same? Simple.
What do you mean with simple?
maybe
Italian is the most simple for me.
that's like the by critics, you know.
No,
that's English.
I think, yes, maybe there are languages that are, I would say Hawaiian that is using 13 letters. Maybe if you say simple, like it depends on how you also define simplicity and complexity. I think tomorrow we will have a talk on complexity.
Yes.
Yes,
Good job.
thank you.
I have a question for like your language selection, because I think I was missing Vietnamese.
Ah.
Really interesting because all the words are really short and there's lots of diacritics.
Mhm.
So maybe I missed how you decided what languages to look at.
Okay, the way it's a very good question because I decided to take out Vietnamese. No, the first thing is that languages have been decided and selected in relation to this corpus that I could find. So I needed the Bible of all the languages, and for simplicity, at one point I found out this. I think it was a project that was already holding this kind of text with for different languages that were. So I started with 70, then I got to 40 approximately. And Vietnamese, like also there was also another language that I think it was I don't remember, so I will not mention. But Vietnamese is an extreme case of Latin script usage. So there, I think it was more clear the diversity and the different texture that could have come out. So this is why I just put it on a side. I hope I to not have done something bad.
Really interesting.
I think so.
Where Vietnamese would land.
Yes.
Yeah, but that would be the very, very, very far end of the spectrum because of the stacking accent.
Yeah, maybe it would have been an outlier of the project. So I just took out the outliers before now. Or maybe not.
Makes sense because you can, let's say, you can shift the parameters coming such an extreme case
Mhm.
into us in specialists in statistics.
Yes.
In fact, is right, because the word length in Vietnamese is practically constant. Word
Mhm.
themes, so we have three of
It's just in terms of verticality, yes.
Yes.
Yeah, it's interesting, the clustering, so it showed really clearly that the higher level clades in the structural analysis like they showed up in the PLSDA or the
Yes.
the PCA looking thing. Did any of the lower level clays show up in the PCA? And if not, do you plan on doing kind of PCAs within the cluster? So like not just the 4 groups within the group, when you had a bifurcation into kind of 2 subclusters,
Mhm.
what did that look like in the PLSDA, this one? Like, could you see the lower level structures here?
The low, okay, so okay.
We need to end the session. So
Yeah. Yes, no, I will be fast because it's not really my field, but I think maybe yes, for understanding how languages are moving inside the cluster, it could be done something like that. Like, you mean like to apply to color the graph inside the language cluster, right?
Oh,
Yes, okay.
very good. Thank you very much.
Thank you.
On then. Yeah.
so,